Okay, so today we're going over the distance and the midpoint formula. These are two boring formulas. Just a heads up, they're really dry, a bunch of numbers, a bunch of variables, but at the same time they're pretty simple and easy to understand. But we can't just stop playing around with triangles, right? I'm going to show you today the distance and the midpoint formula and how one of them relates to the Pythagorean theorem. Okay, so to begin, I want to go over the distance formula. Distance, oh man, this one's frankly, it's terrible. It's awful. The distance formula is for one reason only. Let's say you're looking at a coordinate plane and you've got one line. And somebody says, okay, this line starts at this point and ends at this point. Give me the exact length that this line is. Isn't that awful? Oh man, this actually though is most likely going to be used in your real life. If you're going to be going over how long your roof is going to have to be, how much you're going to have to pay for your roof, this is going to be important. If you're going over landscaping, this is going to be important. So honestly, I hate to say it, but this is a part of math that you'll actually most likely use in real life. Because who wants to get up on top of a roof in the middle of summer when it's blazing hot outside and put a tape measure on each end? You're going to have to be able to do this mathematically. Now, the distance formula, I'm just going to put the D for distance formula. Now, the distance formula is actually a lot simpler than it looks. It looks really complex, and I'll explain why. But it's actually pretty darn simple. So you have a little x sub 2 minus x sub 1, and then we'll square that, and then we'll do plus y sub 2 minus y sub 1, and square that as well, and keep all of this underneath the square root. Wow, is that confusing or what? Now, I'm going to give you an example real quick as I drop my pen. I'm going to give you an example real quick so we can walk through this. Now, let's do x for example, not ex-girlfriend. Okay, now, your example is, let's say we have a line that starts on 2, 3 and ends on 4, 5. This is a pretty darn short line. It's only about like that. It's angled a little bit and it looks funny, but I mean the kids will all make fun of it because it's tiny, and it doesn't like being called tiny because he has to look up to the other kids. But we're still going to find out exactly how long this line is. Now, here's where everything on this formula should begin to make sense. Remember how when we have coordinates, they're always set up x, y. X, y. Oops, not x1, x, y. Now, the one on your left, 2, 3, let's call this coordinate number 1. And let's call this coordinate number 2. So, we're going to take the x from coordinate number 2, or x sub 2, which would be 4, and subtract the x from coordinate number 1, or x sub 1, which would be 2. We'll square that. And then let's take the y from coordinate number 2, or y sub 2, which would be 5, minus, and let's subtract the y from coordinate number 1, or y sub 1. See how this begins to make a little bit more sense as you see examples? And we'll square that. Now, let's figure this out. So we'll have the square root of 2 squared plus 5 minus 3 is 2 squared. And that's going to end up being 4 plus 4. We'll have the square root of 8. Now you can leave it like this, or you can put it equal to 2 square root 2. That's going to be it simplified. And if you guys don't know how to do that, don't really worry about it, but you guys definitely should. Now, the distance formula actually is a unique, interesting twist on the Pythagorean theorem. Don't believe me, do you? I saw that one coming. Of course you guys won't believe me. You don't believe anything I say. Which is too bad because I'm the one teaching you. Let's get 5 here. Yeah, we need to do 5. 1, 2, 3, 4, 5. Now, the first one is at 2, 3. So we have 2, 1, 2, 3. So we have our point here. And let me change color for you guys. Let's go green. Yeah. Okay, so we have our point here for the line. And then our next one is at 4, 5. So 4, 5. Once again, here's our tiny, itty bitty little line. It doesn't look so tiny because I've got the graph all spread out. Now, what happens when we draw these funny dotted lines? Granted, I know it looks like junk, but we just created a triangle. Now, let's say this is our length we want to find. So this is going to be D. This side here is simply y sub 2 minus y sub 1. Because what we're doing is we're taking the y values and finding the height. Here, we're taking x sub 2 minus x sub 1. So now we're taking the x values and we're finding the length. Now, how we're doing this now is see how we have the y values here and the x values here. You know how the Pythagorean theorem is a squared plus b squared equals c squared? Well, we now have a, b, and c. So we need to square a and b, which we do right in here. Now, with that, we're going to be able to find the length and the height squared equals d squared. But to get rid of that d squared, we take the square root over here. The distance formula is really nothing except finding the Pythagorean theorem to find the length of a line. Isn't that awful? I mean, you guys finally think that you're done with triangles. We're going to go on to the length of lines, and no, this is nothing but a little bit of a different way of writing the Pythagorean theorem, and it gives you the exact same results. Now, continuing on though, let's go on to midpoint. Midpoint is the easiest thing you will ever do in coordinate geometry and trigonometry. Midpoint is nothing except for x sub 1 plus x sub 2 over 2, and then y sub 1 plus y sub 2 over 2. Wow, doesn't that look complicated or what? It's actually extremely simple. Because if you remember, don't let these subscripts get in your way. A bunch of people see these subscripts and they go, whoa, 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 whoa. Don't let that happen to you. Look at these subscripts just as numbers. So, for example, let's say, once again, we have the points 2, 3, and 4, 5. Oops. 4, 5. Now, if we use this, we'll have, remember, these are x, y, x, y. Those are terrible x's, aren't they? Okay, now, if we have x of 1, x of the first coordinate, and x of 2, x of the second coordinate, that will be 4 plus 6, or, 4 plus 2. So, we end up with 6 over 2, and then we end up with y sub 1 plus y sub 2, so 3 plus 5, which as we all know is 8. 8 over 2. You can simplify this and you get the answer 3, 4. Now, I'm not going to lie. I don't know many occasions you use the midpoint. But at the same time, this is so darn simple that you should be able to remember this forever. Now, the midpoint, all it does is when you find the two points, you're going to find the third one right in the middle. I mean, you're taking the average. This is extremely simple. Now, if you need any help with either the midpoint or the distance formula, and you have any questions or comments or concerns or even sarcastic remarks, go ahead and type them up in the comment section below. And we'll have either myself or Mr. Hemphill get back to you as soon as we can. Until next time.